Every single time you click that Buy Now button, you're actually kicking off this incredible, hidden journey for your data. So today, we're going to pull back the curtain and explore the two completely different worlds that your data lives in. You've got the lightning-fast world of real-time transactions, and then you have the deep, insightful world of large-scale analysis.
Okay, so let's jump right in with a question I'm pretty sure you've thought about before. How is it that your banking app is, well, instant, you can move money in a split second, but then at work, when someone needs the big quarterly sales report, it feels like it takes an eternity to generate? I mean, it's all just data, right? Well, it turns out they are handled by totally different types of systems, each one built for a very specific job.
So, let's start with what I call the spark. That split-second moment when you hit Confirm Purchase. This is the world of instant transactions. And in this world, systems are built for one thing and one thing only: speed. We're talking about booking a flight, buying a coffee, or a warehouse system updating its inventory the very microsecond a package is scanned. It has to be now, and it has to be right.
Now, the system that makes all of this magic happen is called OLTP, which stands for Online Transaction Processing. The best way to think about it is as the digital cash register of a business. Its entire reason for being is to process a huge number of small, simple transactions, like ringing up one sale at a time, as fast and as accurately as humanly, digitally possible. So let's take a look at the DNA of these systems. Their entire existence is this constant balancing act between raw speed and perfect data integrity. They're not designed for you to ask big, complicated questions. No, they're built for super simple atomic actions. Add a record, update a record, delete a record. That's it. Because in the world of banking or e-commerce, there is absolutely zero room for error. Every single transaction has to be flawless and has to be instantaneous.
Okay, so we get it. The database is built for speed. But there's a piece missing here. How does your phone app or a website actually send its request to that database and get a reply back in what feels like no time at all? The secret here is a protocol called TDS, or Tabular Data Stream. Just think of it as a dedicated, high-speed courier. It takes your request, something like buy the specific item, wraps it up in a secure package, and literally sprints to the database. Then, it waits for the database to give the thumbs up, sale complete, inventory is adjusted, and it races right back with the confirmation. It's really the unsung hero that makes all of this real-time interaction even possible.
Right, so your purchase is done. The transaction is logged. But really, that's just the start of your data's long journey. A single transaction is, of course, super important for running the business day to day, but if you want to actually understand the business, you need to look at millions of them all together. And that brings us to the next really big question. Your order is safely tucked away in the system, but what's the bigger story it can tell? What were the most popular products this month? Which parts of the country are buying the most? Our OLTP system, that digital cash register, it just isn't built to answer these huge questions. And for that, the data needs to go to a whole new destination. So, welcome to the data's final stop, the analytics powerhouse. This is where all those individual little data points come together to tell a much, much larger story. We're going to use a really popular example, Amazon Redshift, to help us understand how these systems are engineered to sift through mountains of data just to find those little golden nuggets of insight.
The technology powering this is called OLAP, or Online Analytical Processing. Now, if OLTP was the cash register, think of OLAP as the company's entire accounting department. Its job isn't to handle one sale at a time, but to take all the receipts from the day, the month, the year, and find the patterns, the trends, and all the valuable insights hidden inside.
So what is the secret to this incredible analytical speed? It actually all boils down to how the data is stored. On the left, you see row storage. That's what OLTP systems use. All the information for a single transaction is stored together, just like a row in a spreadsheet. This is fantastic for quickly grabbing all the details about one specific order. But on the right, you see columnar storage. This is Redshift's secret weapon. It stores all the values from a single column together. So if you want to know the total sales, the system only has to read the sales column, and it can completely ignore all the other data. This is what makes it possible to analyze millions of records in seconds. It's a game changer.
Now, inside Redshift, the name of the game is divide and conquer. It uses this really cool technique called massively parallel processing. So imagine you have a gigantic jigsaw puzzle to solve. Instead of one person working on it, you have a whole army of people, and each one is working on their own small section. That's basically what Redshift does. It breaks down a big, complex query and has multiple computers work on it all at the same time. This is why it's so good at reading huge amounts of data, and also why data is loaded in big batches. It's like giving each worker a giant chunk of the puzzle to solve all at once.
So, what we have here are these two incredibly powerful but very different systems. And they're not enemies, they're partners. Let's take a look at how they come together to form a single, powerful data ecosystem.
This chart really lays it all out perfectly. Just look at the latency. OLTP is all about milliseconds, while Redshift is thinking in seconds, maybe even minutes. And look at the primary use. OLTP is for that real-time processing, while Redshift is for batch analytics. Each one is a specialist, perfectly tuned for its specific job. You know, you wouldn't use a race car to haul furniture, and you definitely wouldn't use a moving truck to try and win the Grand Prix. So let's follow a single piece of data on its journey from start to finish. It begins in the OLTP database the moment you make a purchase. Then, this process called Change Data Capture, or CDC, acts like a lookout. It spots that new transaction and sends a copy on its way. This copy first lands in what's called a staging area, which is kind of like a workshop where it gets cleaned up, formatted, and combined with other data. Once it's all ready, it's loaded in a big batch into Redshift. And from there, business analysts can use their tools to query all that data and find those amazing insights. That right there is the modern data pipeline in action.
Okay, so understanding the difference is one thing, but using them correctly is a whole other ballgame. Let's cover some best practices and, just as important, what you should not do.
This is so critical. Probably the biggest mistake people make is using the wrong tool for the job. You should never, ever run a massive, complex report on your live transactional database right in the middle of business hours. You'll just slow everything down to a crawl for your actual customers. And on the flip side, don't try to use a data warehouse like Redshift to power your website's shopping cart. It just wasn't built for that kind of fast, single-item interaction.
For your OLTP system, you have to think efficiency. Keep those transactions super short and to the point. Use indexes. They're kind of like the index in the back of a book to help the database find information fast without having to read every single page. And you've got to watch out for things called deadlocks, which are basically like two people trying to go through a revolving door at the same time in opposite directions. Everything just grinds to a halt.
Now for Redshift, it's all about strategic organization. You need to give it a solid blueprint for how to store and sort data. That's what distribution and sort keys are for, just to make your queries as fast as they can possibly be. And always load data in big batches. It's so much more efficient. And, just like a librarian has to reshelf books and update the card catalog, you need to regularly run maintenance operations to keep your data warehouse organized and running at its best.
If you only take one single thing away from this whole explainer, please let it be this quote. It just perfectly captures the relationship. OLTP is the engine that keeps the business running, processing every single order, every payment, every day. OLAP, well, OLAP is the dashboard that tells you where the business has been, where it is right now, and helps you decide where to go next.
But of course, the tech world never, ever stands still. The lines between these two worlds are actually starting to blur a little bit. We're seeing new hybrid databases that are trying to do both jobs, and technologies that allow for almost real-time analytics. The data warehouse isn't just for looking at the past anymore, it's quickly becoming the platform for predicting the future with AI.
And that leaves us with a final, thought-provoking question for you. As all these systems get faster and smarter, will we one day just have a single system that can do it all? Will the need for this whole complex data journey from one world to another just vanish? The future of data is being written as we speak, and it is going to be incredibly exciting to watch. Thanks so much for joining me.